hydrocarbons. This is chapter 29. So we fast forward a whole bunch, but this is one of my favorites, so I couldn't not do it. So chapter 29, hydrocarbons. Hydrocarbons are composed of hydrogen, and carbon. We talked about hydrocarbons briefly in, I think, chapter 7. This chapter is going to be all about hydrocarbons, naming, drawing, functions, all kinds of good stuff. So we start with the alkanes. The alkanes are a family of hydrocarbons that go by this formula: CnHn plus 2, which means if we have C4, we can calculate how many hydrogens we would need. So actually, let's fix this because it's 2n plus 2. There we go. Okay, so hydrogens would be 2 times 4, which is 8, plus 2, which is 10. If we did C10, we would need 22 hydrogens, because it would be 10 times 2, which is 20, plus 2, which is 22. So alkanes. The other significant part of the alkane family is they are, of course, all single bonds. And you would probably notice that if you were to draw these structures. The only way to get all of those hydrogens fit around that number of carbons is to have only single bonds. Remember, throughout this chapter, always and forever, carbon really likes 4 bonds. And that can be in any form. So we can have 4 single bonds, 2 double bonds, 1 triple, and 1 single, or 1 double bond and 2 single. Anyway, any combination, they will have 4 pairs shared electrons, meaning there's no unshared pairs on carbon. Carbon really likes to form bonds. So we are going to look at some examples that I have drawn here, and we're going to name them. First of all, note all of the single bonds, all of the hydrogens everywhere, and the fact that carbon has 4 bonds. No unshared pairs of electrons. Here is a quick review of the prefixes that we use for a number of carbons. Again, these are repeats from a long time ago. If there's 1 carbon, we use the prefix meth. 2 carbons is F. 3 is prop. 4 is bute. 5 pent. 6 hex. 7 hept. 8 oct. 9 non. 10 is dec. There are more. It does not end at 10, but we probably won't ever use more than 10 because that's quite a lot of carbons. So, simple structures to start with. This has one carbon, so we give it the prefix meth. This has 1, 2, 3, 4, 5 carbons, so it has the prefix pent. This one has 1, 2, 3, 4, 5, 6, 7, 8 carbons, so it gets the prefix oct. The other very important part is the ending. And since they are all single bonds, they end with ane. Much like the word alkane, ane. There is not a coincidence there. You will see in the next few weeks that we study alkenes that end in ene and alkynes which end in yne, which maybe you remember means double and triple bonds. So to finish these up, we're going to put the ending on. There's pentane, methane, octane, and this little guy is a ring structure, 1, 2, 3, 4, 5, 6, which is hex for 6, ane for single bonds, and the thing we need to remember here is that ring structures use the prefix cyclo. So this is cyclohexane. All right, this again, kind of a review of the last time we learned this. This is the thing that makes this chapter brand new and so much fun. So we get to name branched alkanes. And we're going to kind of go down here to the side to talk about a branch or a substituent. Substituent's probably the fancier word for this, but branch is acceptable. I probably call it a branch more often than I do a substituent, but anyway, either one works. A group of atoms that is connected to the main chain. The main chain is going to be the longest chain of atoms or chain of carbons in the molecule. And something to be aware of is that the longest chain might not be straight. I draw them straight to begin with to get us started, but as we get better and better at this, the longest chain we have to be very aware of is not necessarily going to be in a straight line. Today we're going to keep things very simple. We're going to only use 3 different branches, and they are down here. In a few days or weeks, we're going to learn different types of branches or substituents. But today we're going to keep it very, very simple. If we have one carbon, a branch of one carbon, this is called a methyl group. So we use the prefix meth for one carbon, and then we give it the little ending of YL, methyl. If we have a branch of 2 carbons, we call it ethyl. Eth, again, for the fact that we have 2 carbons there. And the YL indicates that it's a branch. And then 3, you could probably guess, is a branch of 3 carbons hooked onto a longer chain, and the 3 carbon branch is named propyl. Prop for 3 carbons and then the YL ending. Okay, we have some guidelines. I don't know that these are necessarily rules or a step-by-step procedure. I'm not sure. We'll just call them guidelines. First thing, identify the longest carbon chain within the molecule. Again, note, it might not be straight. We'll say linear, that sounds fancier. So don't be tricked if it is crooked and jagged and something like that. So we are going to kind of do this, read this step and then see what it looks like in a molecule. I'm going to use this one as my example. Okay, for this right here, there's our longest chain. We have 1, 2, 3, 4, 5, 6, 7 carbons long. That is the longest chain of carbons. So I've identified my longest chain. Now I'm going to number that carbon chain so that the branches have the lowest numbers. So we could number it from left to right, and we would get a branch on carbon 5, and we would get, so this is what we're talking about. This is a branch, and this is a branch now because it's not part of the main chain. So it occurs on carbon 5 and carbon 6. But can I number in a different way so that those branches have smaller numbers? And I can number from right to left, which seems backwards, but it still works. So now my branches are on the 2nd carbon and the 3rd carbon, which is lower than the 5th and the 6th carbon. So I want to number in this direction. So I'm going to leave the numbers there. Now I'm going to remember to use a dash or a hyphen. I don't really know what the difference is. I know there is one, but anyway, dash or hyphen to separate the branch name and the main chain. I'm then going to use a hyphen to separate no, that is not okay. Sorry guys. Let's fix this. Going to use a hyphen to separate the number of carbon and the branch name. I'm going to use commas between numbers if I have more than one of the same branch. The 4th thing to remember is to use alphabetical order. For multiple branches. Okay, let's see what some of these things actually look like. Okay, back here. I'm going to name my longest chain. So my longest chain is 7, which means I have heptane. And then I have branches. I have a methyl on the second carbon and a methyl on the third carbon. So I'm going to say 2, 3. Those are the numbers of my carbons. And I have 2 methyls. So that is dimethylheptane. I do not separate the branch from the main chain. So dimethylheptane is one word. All right, let's do this one up here. Longest chain is right here. I want to number so that my one branch has the smallest number. So I'm going to go from left to right. That is butane. My branch is just 1 carbon, so that's methyl. It's on the second carbon of my chain, so that's 2-methylbutane. Over here, longest chain looks like this. You could do this too. It's not going to change your answer. I'm going to number that longest chain so that my branch has the smallest number. My longest chain name is hexane because it is 6 carbons long. I have a methyl on the second carbon, so 2-methylhexane. What else? Let's go down here. Longest chain. 1, 2, 3, 4. In this case, I could number from left to right or right to left, and my branches are going to end up with the same numbers. So this becomes 2, 3 dimethylbutane. Again, it's a little bit repetitive, the fact that we list 2 numbers here to indicate 2 different carbons, and we use di, which is a prefix for 2. So 2 methyl groups, and they are located on the second and on the third carbon. Okay, the best way to get good at this is to do a lot of it. So I have lots of examples for us to go through, and then for your homework, you get molecules to name and draw on your own. So this one looks wild and crazy, and I'm not sure, but I think 1, 2, 3, 4, 5, 6, 7, 8, 9. I think if we do that, again, this is going to end up, if we do this, that's going to end up the same thing. Okay, so 9 is what I counted. So that is nonane. And I think we want to number from this direction. 3, 4. Okay, all of our branches are methyls. 1, 2, 3, 4, 5. 5 methyls. Okay, I'm going to number, write my numbers in numerical order. So 2, 4, 5, 6, and there's 2 on the 6th carbon, and we do write the 6 twice. 1, 2, 3, 4, 5 methyls. So pentamethylnonane would be the name of this crazy thing. Okay, more down here. Like I said, the best way to get good at this is to practice. So I am going to do more. So this is 2-methyl butane. One, two, three, four, five, six. That or this 1, 2, 3, 4, 5, 6. Still a chain of 6 carbons. It's not going to change our answer. I'm going to number this direction because we get 2 and 4. If we numbered from the other direction, it would be 3 and 5. 2 and 4 are smaller than 3 and 5. This starts out as hexane. And we have, this is 2 different branches now. So the second carbon has a methyl. The 4th carbon has an ethyl because it's 2 carbons long. So ethyl comes before methyl because E comes before M in the alphabet. So 4-ethyl 2-methyl hexane. This is a perfect example as to why you cannot have branches on the first or the last carbon, because they're not really branches. It's just the longest chain that's twisted. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 is nonane. 1, 2, 3, 4, 5, 6, 7, 8, 9. The 5th carbon branch is an ethyl. And ethyl in alphabetical order comes before methyl, so 5-ethyl. And then we have 3, 4, 7 trimethyl nonane. Here is another one that has a crooked main chain. I believe we want to number in this direction. This is an ethyl. So 3-ethyl 4-methyl heptane. I think if you can name them, then doing the opposite, drawing, becomes very, very easy, which is why I emphasize naming them first. But here is what drawing would look like. I'm going to start with the main chain, and I'm going to draw them as simple as possible, meaning I have heptane. I'm going to draw a straight 1, 2, 3, 4, 5, 6, 7, a straight chain of carbon atoms. No, you do not have to draw the hydrogens because it's crazy. And then on the 3rd carbon, I'm going to draw methyl. 1, 2, 3, methyl. And there we go. That's all we have to do. Hexane is 6 carbons. On the 2nd and the 4th, I have a methyl group. So 2,4-dimethylhexane. You could draw them both up, one up, one down. It does not matter. 3-ethyl pentane. 1, 2, 3, 4, 5. And on the 3rd carbon, I have an ethyl, which is 2 carbon long. Here we go, another pentane. And on the 2nd carbon, I have an ethyl. On the 3rd and the 4th, I have a methyl group. And this is why you should always check your work before you make YouTube videos, because this one is not really named correctly, because 1, 2, 3, 4, 5, 6, as you can see, there's a chain of 6 carbons. So it should actually be called 2, 3, 4 trimethyl hexane. But it's too late now. I'm not going to re-record this. That's just going to have to be there forever. And wow, I don't even know how I did this. That is what that is. Dang it. Whew. Okay. Anyway, I'd like to just pretend like this didn't happen. But it did happen. Not on purpose. Total accident. That's what it is. Anyway, okay. Let's see if this very last one is any better. Okay, butane. 1, 2, 3, 4. On the second carbon, I have 2 methyls, so 1 up and 1 down. On the third carbon, I have an ethyl group, which is 2 carbons long, which means I also made a mistake here because that now is the longest chain. 1, 2, 3, 4, 5. So anyway, the better name for this one would be 2, 2, 3, right? 1, 2, 2, 3 trimethyl pentane. All right, well, I learned a lesson. Hopefully you learned a little bit about how to write and name things also.